QGL widget, and in Qt 5, it's called QOpenGL widget. And if you're writing code now, just ignore the QGL widget. You need QOpenGL is the way to go. You know, this is the new one, and it's actually part of the Qt GUI module, which is the module you're going to pull in if you're doing anything visual. And then there's the QtOpenGL module, which is now deprecated. But of course, all the functionality that was in that module has been updated and moved into Qt GUI. And another API that you may have heard of, maybe are using right now, but shouldn't be, is QGraphics View. So this was the way to do everything, the cool new kid on the block when I joined the Qt team, QGraphics View. And it was neat at the time, and we had this really neat demo that had like many thousands of chips. And it was really good at rendering these chips, but it was kind of optimized for this demo by default, and you had to trick it into doing all kinds of things to do regular UIs. So by default, this is software rendered. It was actually possible to accelerate it with OpenGL using setting the viewport of the graphics view to OpenGL. But really, that just meant that it was using the OpenGL paint engine of QPainter, which was just a really terrible way to do OpenGL. So in general, like we just say, if you're using graphics view now, that's fine for now. But if you're doing a new project, you know, use QtQuick. Every use case for graphics view has been superseded by QtQuick 2. And that also means that any classes that start with QGraphics, just avoid them. So conclusions about widgets, use widgets. Widgets are good. This is, if you're trying to create a traditional desktop app that looks native, you know, think about, you know, the IDEs you're using now. That's the kind of interfaces that you can create with QWidgets. It's very robust. It's very mature and stable. And the actual rendering in the software context, there's no hard OpenGL requirement, and you can render. It's a very, very good thing. Very good thing. And it's also easy to embed native stuff. One of the challenges is, of course, styling can be hard. Quick question?
How about the catch up with the OS? You know, the latest operating system, the Windows 10 or later, like also Mac has later. How about the
you're asking about in the more recent OS releases, how true is this? And I think that in recent releases, it's actually been, things have been changing. UIs are getting, the new versions of OSs are getting closer to their mobile equivalents, and traditional desktop apps and their styling, the same doesn't apply. I think maybe the comparison is, compare WinRT or the new Windows 10 style versus the Win32. So in the Win32 world, QWidgets is perfect. In the more modern world, there it's probably more appropriate for QtQuick. So and this comes down to you know, the touch-friendly UIs, the animated GUIs. You're familiar with mobiles and mobile devices, tablet devices. That's fairly difficult to do, and it's actually part of the reasons why we did QtQuick. One of the things, if you've been following Qt development, you might notice there aren't a whole lot of features, you know, or if any features being added to Qt. There's definitely bug fixes being added to QWidgets, but it's not something that we're actively working on. We consider it mature and stable and done, but that may change in the near future. I mean, as you said, like with the new OSs coming out, there may be additional things that we need to add that still make sense for traditional desktop apps, but it fit into the widgets way of doing things. And of course, graphics view there, don't use it. So now move on to the other side of things, which is QtQuick, which is the other recommended way, you know, to get, you know, make your application the base way. So QtQuick is a declarative UI framework. Got a little video here. Is it playing? I hope so. No, it doesn't look like it's playing. Come on now, behave. There we go. So QtQuick, it has a declarative language that goes along with it. It's a JSON-like syntax. It's not entirely declarative in the sense that you can also embed JavaScript code into your QML. But it actually makes it possible to make very touch-friendly, fluid UIs. And before it was designed in Nokia with the mobile phone use case in mind. Trying to catch up to what was going on with the iPhone, and we weren't able to do that kind of easily do that with widgets. So QtQuick was developed, and one of the big advantages there is that we can actually take advantage of the hardware available on mobile. So if the mobile devices and the embedded devices were actually coming with graphical processors, and if we're just doing software rendering, that's just draining your battery. So we were able to take advantage of that hardware. So there's one big thing here is that there's actually two versions of QtQuick. One that we did for Qt 4, which was the original QtQuick, and then QtQuick 2. So the key here is to do not write any more QtQuick 1 code. It is deprecated, and I think as of 5.8, there is no reason to use QtQuick 1, not even the software rendering case. So it was actually based on Graphics View, which we already know is, do not use it. It also has another deprecated module or two, like QtScript. QtScript was replaced with the new v4-based scripting engine that comes with the QtQML module. And if you actually are using QtScript, it has an ancient, really old version of JavaScript core in it. So, and a bunch of buggy behavior that also comes with it. So it's not fun to deal with. And so do not use it. Port your existing code to QtQuick 2, which should be it's not 100% source compatible, but very close. It's usually a difference of changing one line and maybe editing a few object names. So with QtQuick 2, we actually have our own JavaScript engine that we maintain ourselves. We're not pulling it in from anyone else anymore. And it's actually specialized for our usage of JavaScript. So we actually can know about the types and not have to convert back and forth over and over and over again to and from the JavaScript formats. There is so the big thing with QtQuick 2 was that when we originally introduced it, it had a hard requirement on OpenGL, specifically OpenGL 2 and OpenGL ES2. And we thought that originally that this wouldn't be a problem. In the future, every device would have OpenGL. Well, even one of the fundamental assumptions, say for example Windows, doesn't even guarantee that you'll have OpenGL 2.0. So your customers might not even have that. So then we have this whole issue of, how do you deal with OpenGL, the OpenGL dependency. Same thing with mobile devices. Well, for the most part, they have it. But embedded devices, there's still today application processors coming out that don't have OpenGL ES2 support. So to remedy that, I guess it was Qt 5.4, we actually introduced the QtQuick 2D renderer, which was a software backend for that. And with Qt 5.8, I guess originally it was a commercial-only module. With Qt 5.8, it's actually part of QtQuick. So it's open source, it's available to everyone, and if you don't have OpenGL, you can still build QtQuick, and it'll automatically use the software renderer. So it's the same as it worked in QtQuick 1. Just, by default, it's going to use the hardware-accelerated paths. And we also, when we added that into QtQuick, we actually added the possibility to render with any technology. So we can have Vulkan renders. We have an experimental DirectX 12 renderer right now. So if you're on Windows 10, you can use that. And there'll be more on that. And actually, the next talk that'll be in this room will expand on that. Just like with the Qt widgets, we also have a what you see is what you get editor for QtQuick, where you can drag and drop your controls onto this form or into this area, and you can change properties. You can set all these things up, and then you can take that and bind those things to your actual application logic. So that's actually part of Qt Creator as well. So the next thing about QtQuick is there's another fork. So in addition to there being 2 versions of QtQuick, which of course use QtQuick 2, there's 2 different versions of QtQuick controls, which only work with QtQuick 2. And this is actually, these controls are, it's designed as a replacement for QWidget. So if you're actually doing like desktop style development, you know, you need buttons, you need tabs, you need checkboxes. We wanted to have an easy way so each customer wasn't having to do their own checkbox. So this is our first attempt at this was QtQuick controls, and what we got was something designed primarily for desktop, has a very complex and complete styling API, so every little thing can be changed, but it's also really heavy because all of this is, or almost all of this is done in the QML JavaScript code. So if you take this same thing and put it on an embedded device, it didn't run that great. So, but one of the big advantages is that because we did it a very complex way like we did with QWidgets, we could get a native look and feel. So in this case, I'm showing on Mac how it would look, this gallery control. So it's going to look like a Mac application. And here's a short example of what QtQuick Controls 1 code looked like and what the resulting application looked like. So you can see here, the top level item is an application window. It's going to create a window of a certain size with a certain title. And then we also have the layout system where it's going to have one block of controls on top of the other. And again, it's using the native styling for Mac here. So because QtQuick Controls 1 was quite heavy, we were running on embedded devices, we're trying to sell heavily to our embedded customers, yet what happens in practice is that they need to roll their own controls because our controls were so heavy. So to remedy this, we actually created a second version of QtQuick Controls that was lightweight and very friendly for embedded. Of course, this still works on desktop, but here the mentality was, rather than trying to look native, this is when you want to have your app look the same everywhere, or completely define the look of your UI. So don't even pretend to be native, because in practice you're always only going to be 90% there anyway with this. So we say like, okay, well, you be completely unique, and we can also have something that is very performant everywhere we run. So that also means that any styling code that you wrote for QtQuick Controls 1 won't work for QtQuick Controls 2, but fortunately it's a lot easier as well to do styling with QtQuick Controls 2. And I think there's actually a talk at 4 o'clock this afternoon if you want to know more about QtQuick Controls 2. And here's that same example. And you might notice that that is actually the exact same code from the QtQuick Controls 1. I did miss the import line, but that's the only thing that's different, is just importing QtQuick Controls 2 versus QtQuick Controls 1. And of course it looks different. This is actually the universal style. So the 2 default styles we actually have is one based off of Google's Material Design, and the other based off of Microsoft's universal style. So those are the 2 things we've implemented. And of course this works on embedded devices and desktop devices. It makes sense both places. So then with QtQuick, there's a bunch of built-in components, and if you're not using controls to build up your own components, and you want to have something custom, you're going to have to like build it up from rectangles and pix maps and just bare primitives. But if you want to do something outside of that, say like draw a diagonal line or a curved line, like that's not in QtQuick. You have to do that yourself. You have to create custom items. And so we have several different methods to do that with varying performance penalties. So these are the 4. We'll go over how that actually works. So yes. So the first one is one that's actually a C++ API. It might be very familiar if you're coming from the QWidgets world, where you're given a paint method and you have an area to paint in, and then you can paint whatever you want with QPainter, which QPainter being the imperative painter API. So in this case, in C++, you'd actually implement a subclass of QQuickPaintedItem and re-implement the paint method. And so here, I'm actually drawing a star path. So creating a painter path and then drawing filling a star path to create a star-shaped item. So in this case, what it actually does is it'll create an off-screen surface like a QImage or a frame buffer object, render to that, and then it'll use that content. So one of the big problems with this, though, is that if you paint this every frame, it'll be slow. So one of the keys to using this item effectively is to paint once and then just never change it unless you resize it or have to update it. Like ideally, if you use it this way, it's just a texture. It's like adding an image to your scene. But if you change it every frame, you might want to reconsider. Yes, quick question?
Does that apply to both 1.0 and 2.0 controls?
Yes, it does. Yeah, so QQuick painted item is not part of controls. It's actually part of the core of QQuick. The second item that does roughly the same thing as QQuick painted item is Canvas, what's called Canvas 2D. It's a canvas item for QQuick. And rather than this being a C++ API that you'd implement a custom item in, this is actually a JavaScript or QML API. And so this is actually modeled after the HTML canvas, the Canvas 2D context. So it's actually compatible with the HTML5 version of this. So you can actually take an HTML5 canvas API, like something that actually uses the canvas API, and put that in QQuick, and it'll just work. I think we have a porting guide because I guess with QML, you don't actually have a document object, so you need to remove those references from the API. But for the most part, it's fairly trivial. There's like a 5-step porting guide for JavaScript APIs for this. Of course, the same thing applies. If you're painting every frame, it is really expensive. And of course, if you're using a web framework for this, there's a lot of JavaScript associated with that. And on the desktop, it'll work fine because you have plenty of power to just, or plenty of CPU cycles to just, spend on doing whatever you want. But on an embedded device, yeah, don't go there. Don't even use the Canvas API. Just forget about it. Pretend it doesn't exist because JavaScript is bad on embedded. The less JavaScript you can use, the better. And of course, for those who really care about performance, we have just the standard QQuickItem. And there's a lot of code on the screen, so I'll give you a basic overview. But because of QQuick, the way it works internally, it's just we have this thing called the scene graph API. And really, you can introduce your own nodes into the scene graph. And so in this case, we're actually trying to draw a line, a curved line. And of course, this is a use case I hear quite a bit about. People, how do I draw a line that's not a diagonal rectangle? And so this is how you would do it. You'd actually have to re-implement QQuickItem, and in the update paint node method, you'd have to create a custom geometry. And by default, QQuick's using OpenGL, so it really comes down to what is the geometry and what is the material. So in this case, it's actually the geometry is the individual line segments of this curve, and the material is just a standard OpenGL shader that says, hey, everything's red. If it's on this vertex, it's just red. And the mode for the geometry is actually a line strip. So for every vertex, it's just drawing a line between the individual points. So what we'll get here is, calculate what the individual vertices of the line should be, and then saying, hey, one QSG flat color material, which is just a built-in convenience function for a flat color shader material. And then you get your red line. This is the fastest way to do things. And, the way that, if you have something performance critical, go this route. But it is harder. I definitely admit that it's not for the faint of heart, but it's definitely the way to go if you want to get those 60 FPS or 120 FPS or whatever you need. So yeah, conclusions about QtQuick. Definitely use QtQuick 2, never QtQuick 1. And Canvas and Painter item, they're cool, but as much as you can, draw once and then never update again. Use it, just have it mapped as a texture. And of course, try to use C++ as much, the C++ APIs for QtQuick as much as possible. In QtQuick, the lesson we've learned, especially on embedded, is that it's a declarative API, use it as one. So the less JavaScript code you have, the better. Okay, so the next realm of things is actually 3D. And we have multiple options for getting 3D content into your Qt application. So really it comes down to OpenGL, Qt3D, and Canvas 3D. First, and probably the newest way to get the 3D content into your application is the Qt3D module. And this is actually a high-level way of doing it. So you're dealing with the high-level primitives in 3D, like models, materials, and where does the camera go? What texture does this thing use? And this can get kind of complicated. So there's actually a pretty neat feature in Qt3D, which is this concept of a frame graph. Because in 3D rendering, you know, I guess the simple way of looking at it is just this forward rendering where, you know, you have the contents of your scene, you only render it once. You're going to draw this thing with this material, and you get a scene like you see here, which it actually has 4 lights, and that's the only 4 lights it'll ever have, because that's just because of the limitations of how OpenGL ES2 works. If we're doing a forward render, we can only pass that many attributes into the scene at once. But you also have because of the frame graph, you can actually do deferred rendering. So you can actually say, render this much into this frame, do it this way, send this material here, and then blend this with it. Like, it's very detailed in how you can do it. So it's a very simple API, but also a very flexible API as well. The second way to get 3D content into your QtQuick scene, well, I think Canvas 3D is QtQuick only, is actually the Canvas 3D module. And this is comparable to the Canvas item. If the Canvas item is matching context 2D, the Canvas 3D module is actually replicating, WebGL, the WebGL context. So you're actually able to do and use WebGL in QtQuick rather than the browser. So you can take existing WebGL frameworks or JavaScript frameworks and use that in QtQuick as well. And of course, I think the most popular one for this is this 3GS, and we actually provide support for 3GS, and that's actually what this demo example is using here. And of course, I think the text is probably really small on this one, but this shows an example of how much, or the kind of thing that you would do to get Canvas 3D applications running. Which it basically comes down to the JavaScript you would have written for your browser. You still have to do that, and then we have some entry points for how to actually get to that canvas in QML. So this one I don't recommend using. I mean, you can definitely on desktop. It's a prototype kind of platform, but if you intend to do this on an embedded device, yeah, just don't. It's very heavy. Again, it comes down to JavaScript performance. And on desktop, it's fine. It works fine in your browser. It'll work even better in QtQuick. But on an embedded device, it's crazy heavy. And the other interesting case, I think this is probably the same example I showed for the widgets, but you can actually you can render any OpenGL content in your QtQuick scene. So that means that any external renderer that you have that can render to an FBO or just an OpenGL context, you can use that in your QtQuick scene as well. So there's a couple of different ways to do that in QtQuick, but it really comes down to rendering your content with a given context, or having a shared context in OpenGL and then mapping that FBO into your scene. So yeah, I think I went over the, the advantages and disadvantages already. I think with Qt3D, like right now, I think the best example I like to think of is like if you're doing your car IVI thing and you want to have that 3D car rotating with the doors opening, Qt3D is perfect for that. It's a car model and you're animating the doors, and that's all ready to go because you're just dealing with the simple load this model with this material. Canvas 3D, it's the whole WebGL thing. So it's basically doing the C API for OpenGL in JavaScript, and then having the potential to use the JavaScript or the JavaScript frameworks that exist already. And basically, if you're doing OpenGL, it's easy to get that content into Qt. Like, it's a very, very good fit. And then I guess the final branch of choices that we actually have is the hybrid web app approach. So you want to get web app into your application, or you want your application to be basically a web app on an embedded device, for example. So the first thing is WebKit versus WebEngine. I mean, many of you probably have been in the Qt ecosystem for a while, and previously QtWebKit was the way to get web content, or to actually display web content in your application. As of, I think, it was a couple releases ago, QtWebKit's actually deprecated, and it's probably pretty dangerous to use these days because, browsers are very, potentially if you're loading arbitrary HTML content, that's a very big security vulnerability in your application. WebKit is a Apple, it's their thing, and it's WebKit plus JavaScript core was what QtWebKit was actually based off of. Alternatively, we have since moved to QtWebEngine, and this actually happened after the WebKit Blink split, and we actually have Chromium as the backend for QtWebEngine with V8. So the QtWebEngine API is about embedding a full web browser stack into your application, which, of course, it sounds huge. It is huge. It's a big dependency. There are QML APIs and C++ APIs, so you can use it in both a widget application and a QtQuick application. And it's best described as a browser for platforms that don't have browsers. So if you're making an embedded device and you want to show web content, this is the way to do it. You're basically running a Chromium browser in your app. That means HTML5. One of the caveats of this is that Chromium, it has an LGPL 2.1 dependency, and we can't do anything about that. If you use QtWebEngine, which its module is LGPL v3 and commercial, the Chromium dependency inside of that is you still have to comply with the LGPL v2 dependency there, no matter what. Just something to keep in mind. So here's a very simple example of a QtWebEngine application. Very, very easy. You just basically have a window and fill that window with a WebEngine view. And the web page, yep, there's your browser. That could be on your embedded device. I think one of the neat things I did just to show a demo one day was I had just a simple low-end embedded device with a screen. I have the Kindle ebook app, the web app, put that on there. Now I have an e-reader. Done. Just that many lines of code. Just change the Qt.io to that web page. So that it's very tempting. Alternatively to QtWebEngine, we actually have a newer module called QtWebView. Yeah, very confusing, but this is actually rather than taking the entire web stack and the kitchen sink, everything, and putting that, bundling that with your app. If you're using a platform that does already have a web browser, then you can embed that into your application. So if you're on iOS, that's Safari. If you're on Windows Phone, that's Edge or IE or whatever they call themselves now. And on Android, that's Chrome. So, in some cases, you're not even allowed to, bundle Chromium yourself on the App Store. I think on iOS, you can actually use QtWebEngine for that reason. But this is actually the solution to that. And this also means that you don't have to deploy 60 megabytes of just QtWebEngine with your app to the App Store. It does come with some caveats, though, because this is a native view that gets packed into your scene, and that's that you can't overlap QML components with the web view. But this will be useful for things where you absolutely have to use a web browser. So, for example, say you're wrapping some kind of web service that requires some kind of OAuth or something that you actually had to go into a web browser, sign in, and say something. This is just the hey, pop up this web view and do this one thing, and then we'll go back to the app, that kind of thing. So I think that's a pretty useful API. So conclusions on that. If your platform has WebView, use WebView. It's nice, but I think for now, I mean, again, this is platforms that have a browser already, and I think in the current release of Qt, that's only the mobile platforms. But I think in the upcoming releases of Qt, it also have the desktop platforms for WebView. On an embedded device, you don't have that luxury because there's no browser. If you have embedded Linux, it's the only things you have there is the things you put there, and if you want a browser, you have to ship it. And this is QtWebEngine's an easy way to have Chromium as your platform on your embedded device. Whether or not that makes sense, we'll see. Just hold off for a few seconds for the questions. Overall, the conclusions of the curse of choice that is Qt, the many choices you have to make. Indeed, there's a lot of ways to do the same thing in Qt. There's a lot of pitfalls if you're not aware of these things. And this is actually something we're in the upcoming releases we're going to try and remedy. We're going to improve the documentation. So the same things that I told you today will be very clear from the get-go for new users of Qt. And so that's an ongoing process. QtWidget is great for native desktop applications. It's not going anywhere. We're not deprecating it. I'm sure whenever Qt 6 eventually comes out, QWidgets will be right there with it. QtQuick's great for mobile and embedded. Definitely embedded. If you're making an embedded product these days, use QtQuick. It's still people making QWidget applications, but especially now in 5.8 with the 2D renderer being part of QtQuick, there's no excuse not to use QtQuick there. 3D content's not a problem with Qt. You have lots of options, and most of them work perfectly well. It's not really a trade-off there. It'll all work well. And with hybrid web applications, yes, that's cool. It works really, really good, but if you're using low-end hardware, you're going to lose a lot of the benefits of using Qt and QtQuick if you're just using it to run a browser, because a browser is inherently heavy. But okay, that is actually all I have, and I'm sure you all have lots of questions.
Please raise your hand, and I'll be happy to bring the mic to you.
Talk about the WebKit, WebKit view and the WebEngine. So in order to use the WebEngine, so is there compiler limitation on the Windows? You have to use in the Visual Studio. You cannot use in the main GW anymore.
Yes. So the question is, are there limitations for using, or compiler limitations for using WebEngine on Windows? And yes, there are. So you can't actually build WebEngine with MingGW if I'm correct. I think you have to use Visual Studio or the Visual C compiler right now. And yeah, I don't think there's a solution for that. I think you have to use Visual Studio there.
Great talk. How about QSS support in QML apps?
So I know that it has been discussed, and I think that the first time it was discussed, they were against it, and I think there has been some experimentation with it, but right now that doesn't exist. The QSS only works with QWidgets.
Okay, and perhaps I misconstrued, but I thought I heard two different stories on QML with embedded. One, that it's preferred, but two, that you have to watch out because of the performance penalty of JavaScript.
Yes.
So
what I actually mean there is that if you're using QtQuick and QML for embedded, and you definitely should use it in a declarative way. So limit yourself and the JavaScript that you actually run in QtQuick. So for example, you can do complex bindings that have inline JavaScript code in your QML. Opt not to do that, and rather just have its declarative structure of the objects in your scene, and any of the complex logic actually do that in the C++ side. That's the preferred method. Yes?
Quick question. When it comes to the 3D Studio for the design team, do you still have them upload PNGs, or are there other kind of file formats you use, any kind of video or render out anything in like a 3D software that did like a video file or anything like that?
You're talking about Qt3D?
Yeah, sorry.
Okay, so the asset conditioning pipeline?
Yeah, so like what you set up something, your design team cuts something up and gives it to you, do you be able to use it inside that canvas?
Okay, so the way that the asset conditioning works with QtQuick is that we actually use libasync to actually take in arbitrary content and then convert that to GLTF, and that's actually we actually have used GLTF as the native conditioned format for Qt3D. So you can just take say a 3ds model and import that into your scene if you want. We also have a tool that if you were to list that in your QMake project, it would convert that to an efficient runtime format rather than the. So we do. You're able to put complex finished models into this scene and just specify them directly.
All right, thank you.
Just the mic will come around.
So you mentioned using the QtQuick views inside of Designer, say, inside of Creator.
Mm-hmm.
So is there any reason why I should worry about, like, say, taking a QML thing and sticking it in a layout and sending signals back and forth? Does that all work?
Yeah, so you should be able to do that. You can have, if you're specifically referring to like having a widget hierarchy that has a QQuick scene inside of it. So that should be possible now. And there's actually a convenience class called QQuickWidget. And so that should take care of most of the details for that and make that work quite well. And that's actually what we're doing in Qt Creator as well. So for example, with the welcome view, when you first open up Qt Creator, that shows all of the examples. That's actually QQuickWidget.
Hi, great talk. I think you mentioned that quick controls 2 were mostly C++. Does that mean you can instantiate them from C++ without a QML engine, or do you still need that?
Yeah, so you do need to use the QML engine. So like the actual implementation of the items is done in C++, but there isn't a public API to actually do that, and you have to do some trickery if you want to.
Okay.
If you need to do that from C++ yourself.
And that actually leads to my second question, because you mentioned QGraphics View is deprecated, but one use case we found is when our item creation is data-driven, like we're trying to create tens of thousands of items very quickly. When we tried to port that to QtQuick, we found we had to create an XML engine. Every item had to go out to JavaScript just to create the control, which is a big performance bottleneck. So I wondered if you thought about any sort of native C++ API for.
Yeah, so that is something that at least we've considered, and it's definitely a pattern that we've seen that needs to be further fleshed out. But I would say that right now it's still roughly the same. I think that you explored, but it's something that we intend to remedy.
Okay. Thank you.
So if you had a fairly large team of developers that weren't familiar with Qt, coming up to speed, how to create a desktop class application, would you recommend QtWidgets or the Qt Controls 1.0 solution, and maybe some insight as to why?
I guess that would depend. I think that the QtQuick way is probably the more future-proof, and especially if they have something that needs to like perform well on, say, a Windows 10 Touch tablet. Like that would be something where if you were going to intend to deploy on a platform that Touch was intended, or one of these convergence platforms where iOS and OS X are kind of converging into one platform. I think if you're forward-looking in that way, then QtQuick would be the way to go. But because it'd be much easier to extend if you needed to. But if it is a traditional desktop application, say a Visual Studio, where you're not going to have people touching the screen, then QWidget should be fine. I think touch and animation are kind of the cutoff point of if you intend for these things, you could do it with widgets, but it's much harder.
One of the things that we're hoping to add into our application is sort of procedural mesh generation. Was that something that I would be able to do in Qt 3D, or is that something I would probably lean towards OpenGL? So there'd be custom mesh generation and manipulation within the app.
Yeah, you can actually do that in Qt 3D right now. My colleague, the guy that sits in the office with me, I think one of the first things he did when he joined the Qt team was actually write a Qt 3D example that was procedurally generating a mesh. So I can guarantee that works.
I was just going to follow up. Is that example available anywhere?
I think it is. I think it may have gone into Qt 3D now. If you look at the 5.8 branch.
Okay, we have time for another question if there is one. All right, seeing none. Thank you, Andy, and thanks for your time and attention. Enjoy Qt World Summit.